Welcome to the AP Systems YC600 and QS1 installation video series. This series will cover the overview, preparation, and installation of the YC600 and QS1 microinverters. This video series, designed for professional solar installers, is not intended to replace the installation manuals, but to provide a brief overview on the installation process of these AP Systems microinverters. Please note there is important information in the manuals that professional installers will want to be aware of. You can find this documentation and additional resources on our website at apsystems.com. Before getting started on installation, professional installers will also want to be sure they have an AP Systems EMA account. An EMA account is necessary to set up homeowner-customer accounts for online monitoring, so be sure to visit our website at apsystems.com and click on the Register link under the Resources tab, or visit apsystems.com/register to fill out the form requesting an EMA account. Before we get started, let's take a quick look at the YC600 and QS1 microinverters and the system components and accessories. The YC600 is a single-phase, dual-module microinverter, which means it connects to two PV modules. The QS1 is a single-phase, 4-module microinverter, which can connect to up to 4 PV modules. YC600 and QS1 microinverters can be conveniently used together on the same circuit. We'll get into the details of how to best mix and match these microinverter models a bit later. Both microinverter units connect to an AC bus or trunk cable, which has accessories including a terminal cap to cap off a terminal that would normally connect to a microinverter, a cable end cap for sealing a cut trunk cable, and an AC extension cable to go around a chimney, for example, as well as male and female connectors to connect the extension cable to the trunk line. On the DC side, there are male and female MC4 caps to cap off unused connectors on the microinverter, and DC extension cables to connect to hard-to-reach PV modules. AP Systems uses a disconnect tool to disengage microinverters from the trunk cable terminal to prevent unintentional disconnection. The AP Systems ECU-R and ECU-C are gateway devices which communicate with the microinverters and relay their signals and production data to our EMA platform in the cloud. These devices use wireless Zigbee to communicate with the microinverters and then require an Ethernet cable or wireless connection to the homeowner's router to backhaul system data to the cloud. Now let's look at a few tools required to complete the microinverter installation. You'll need a socket wrench or power drill with a socket attachment sized appropriately for your racking system. Racking hardware will vary by manufacturer, so be sure to do a fitment check with the microinverters and your racking fasteners before you're on the roof to be sure you've got the right hardware. You'll also want cable zip ties, an AP Systems disconnect tool in case you need to disconnect a microinverter from the trunk cable, and a multimeter to ensure circuit continuity before you install the PV modules. AP Systems cares about your safety and requires that all installers obey the following safety instructions when installing AP Systems microinverters. 1. Only qualified, licensed, and trained solar installation professionals familiar with the requirements for safety, electrical systems, and EMC, and who are authorized to energize, ground, and tag equipment, systems, and circuits in accordance with established safety procedures should be installing AP Systems products. The inverter and balance of the system should only be installed, commissioned, and diagnosed for any issues by qualified personnel. 2. All inverter equipment, cables, connectors, and accessories should be provided by AP Systems or compatible with AP Systems equipment and have markings for electrical safety standards. 3. All electrical system installation, grounding, breaker, and cable sizing and connections must be done in accordance with local electrical codes. 4. Installers should also wear a roof-anchored safety harness and helmet when doing any work on the roof. Before beginning your installation, you'll want to spend some time on microinverter placement and cabling. As both YC600 and QS1 microinverters connect to multiple modules, planning out your connections and cable routes in advance will save you time on the roof. Begin by drawing out your layout map based on your roof measurements, clearly marking the placement of racking and PV modules and where the trunk cable will be routed. Check your regional AP Systems microinverter datasheet to determine how many units can be placed on each circuit. In the US, up to 7 YC600 units can be placed on a single 20-amp breaker in a 240 volt configuration, which accommodates 14 PV modules, or up to 3 QS1 units per 20-amp breaker in 240 volts, which accommodates 12 PV modules. In Europe, any combination of YC600 or QS1 units that will accommodate 14 PV modules can be used. For all other regions, be sure to check the product datasheet from that region. Next, determine where the inverters can best be positioned to connect to the PV modules. One of the benefits of a detailed layout map is that it allows you to set up your gateway in advance, saving you time at the job site. If you choose to pre-plan which specific microinverters will be placed where in your array, you can remove the serial number UID stickers and place them on your array map. You can scan these UIDs using the AP Systems ECU app, so the gateway is plug and play at the job site. Alternatively, you can scan the serial number UIDs after you install the microinverters on the racking by pulling the stickers and building your array map before installing the panels. More information on the process of scanning inverters and using the ECU app can be found in our ECUR video series on our YouTube channel. YC600 layouts are fairly straightforward. For single panel layout in Portrait, the trunk cable terminals are located every 2 meters, which allows the YC600 to be positioned completely under every other PV module. For 2x2 layout, the process is similar, with a new trunk line used for the next row of PV modules. When connecting the YC600 to split cell or half cell PV modules, a DC extension cable may be needed to reach the furthest side of the adjacent PV module. For the QS1, a 2x2 portrait layout is the most convenient whenever possible. Plan to position the PV modules so the junction boxes are placed as close to the inverter as possible to enable connection. For a 1x4 QS1 layout, place the microinverters 4 modules apart, which can be done by simply skipping one terminal on the trunk cable. The unused terminal can be sealed with a terminal cap. Be sure the QS1 is located under the second PV module in the set of 4, so it can easily reach the second and third modules. Plan to use DC extension cables to reach the first and fourth PV modules. The 1x4 portrait layout requires more DC extension cables, which is why the 2x2 layout is recommended whenever possible. In your layout design, be sure to consider where you might need DC extensions to connect to the hard-to-reach PV modules. AC extensions, or whips, are also available if needed to route a trunk cable around a chimney or other roof feature, as well as connectors to create a sealed connection. Using the QS1 and YC600 on the same circuit is simply plug and play, since they use the same trunk cable, connector, and gateway and are fully compatible to be used in the same circuit. If your circuit, for example, has 3 QS1 units, which can connect to 12 PV modules, what happens if you only need 11 modules? You can use 3/4 of the inverter by sealing 2 unused DC connectors on the QS1 microinverter with MC4 caps. The rest of the inverter would function normally. The MPPT is not shared, but independent per channel, so the output on the rest of the channels would remain the same. In a 10-module scenario, you can simply replace one of the QS1 units with a YC600. If you have 9 modules, just use MC4 caps once again to seal the unused DC connectors on the YC600. For 8 modules, simply use 2 QS1 microinverters. Here's an example from the US and European markets regarding combinations of QS1 and YC600 units per branch for those regions. Regions differ on the number of units per branch, so be sure to check the datasheet and installation manual for products sold in your region to determine how many of each microinverter you can use. The rule of thumb for the European region on units per circuit is any combination of QS1 and YC600 microinverters which accommodates 14 PV modules. For the US, it's any combination which remains at or under the 16 amp loading threshold on a 20 amp breaker. Also, here are a couple of tables showing the combinations for Canada and Australia. With your layout plan completed, you're ready to install on the roof. Here are a few general rules to follow when installing AP Systems microinverters. 1. Save yourself setup time with the ECU gateway by plugging it in and connecting it to the homeowner's Wi-Fi first thing. This gives the gateway a chance to download and install any available updates while you install the array. See more tips and ECU setup instructions in the ECUR video series on AP Systems YouTube channel, youtube.com/APSystemsSolar. 2. Never carry the microinverters by the cable. This could unseat the cable from the microinverter and cause the inverter not to function or to function improperly. 3. Do not carry the microinverters by the mounting bracket, as the grounding washer may cause injury. 4. Microinverters should be attached to the rack rails and not directly to the PV module frame. 5. The microinverters should always be fully covered beneath a single PV module. While the microinverters are NEMA 6 IP67 rated, as a good rule of thumb, there should never be any part of the microinverter exposed or placed under the joint of 2 or more PV modules, where water might pass between modules and contact the inverter. 6. This rule also applies to connectors, such as DC and AC extension cable connections. These connections should be under PV modules whenever possible. 7. Be sure the microinverters have at least 3/4 of an inch or 2 centimeters space between the roof and the microinverter to allow for proper airflow. 8. When connecting microinverters to the trunk cable, listen for the audible click from each side of the connector, which tells you the connector is fully seated in the terminal. Once your racking is installed, and with your safety gear in place, mark the inverter placement on the racks where the units will be mounted. Remember to position the inverter completely under the PV module. Lay out your trunk cable to ensure the terminals are positioned correctly with each inverter. Using fastener hardware recommended by your racking provider, mount the microinverters to the rails with a socket wrench or drill with a socket attachment, and confirm the spacing for proper airflow. Both QS1 and YC600 microinverters have a built-in ground wire within the cable. However, be sure to check if external grounding is required for installations in your region. Remember, your installation must comply with all local regulations and compliance standards. Place the microinverter AC cable connectors into their respective trunk cable terminals. Listen for the audible click, which tells you a sealed connection has been made. If you need to disconnect a microinverter from the trunk cable, use the AP Systems disconnect tool. Simply insert the tool fully and pull the connector out of the terminal. After all connections are made, place an AC end cap on the bare end of any trunk cable and use terminal caps to seal any unused terminals. Once the microinverters are connected to the trunk line, use zip ties to secure the trunk cable to the racking. Be sure not to pull the cables too taut and to allow for some slack. Hot and cold temperatures can stretch and tighten cables, so adding a small amount of slack can help to prevent an unintended disconnection. Once ties are completed, be sure to check all connections carefully to ensure none were disconnected in the process. When using connectors, remember to follow the region's color code. For example, in the US, use black for L1, red for L2, and green for protective earth or ground. In Europe, use brown or black for L1, blue for neutral, and green-yellow for protective earth. With the microinverters now in place, if you've not yet built your array map, record which PV modules are feeding which microinverters in the array by simply pulling the serial number UID stickers off each unit in series and placing them on the array map in their corresponding position. Once complete, you'll have the layout diagram you need to build your array map in the EMA. You can also complete your layout using the ECU app. However, if your site is large or complex, the EMA will allow you more flexibility in arranging PV modules in your array layout. Now it's time to place the PV modules. When you first connect each microinverter, the LED light will flash red once, then show 3 short green flashes indicating the inverter checkup was successful. The DC connections should first be made with the PV modules adjacent to the microinverter, with the last connections made to the PV module that will cover the microinverter. For example, with the QS1 in either 2x2 or 1x4 layout, connect to the 3 adjacent PV modules before connecting to the module covering the inverter. Be sure to use MC4 caps to seal any unused DC connectors on the microinverter. Repeat this step for all remaining inverters. With your solar array complete, it's time to set up the gateway unit, which will communicate the production data to the cloud-based monitoring platform where the homeowner can view their solar production online and on their smartphone. These steps are covered in our next video, the ECUR installation series, available on AP Systems YouTube channel, youtube.com/apsystemsolar. When DC power is first applied to the microinverter, it blinks one quick red light, followed by 3 short green blinks. From this point on, it will blink once every 10 seconds while power is applied, and it is communicating with the ECU. If the light is flashing a fast green blink every 2 seconds, this means that the unit is producing power, but is not communicated with the gateway in more than 1 hour. There's an easier way to verify operation than checking microinverter LEDs on the roof. That is, by using the ECU app. To learn how to connect to the ECU using your smartphone and the ECU app, see video 4 of our previously mentioned ECUR installation series on our YouTube channel. Once you connect via Wi-Fi, check the home screen of the ECU app and look for a green dot verifying that you are connected. Next, look for the microinverter icon with the word number next to it. The first number tells you how many microinverters are communicating with the ECU, and the second number tells you how many you've scanned and registered to the ECU. Check to see that these numbers match. If they do, all your microinverters are connected and operating normally. Again, if you have any issues getting connected, be sure to watch the ECUR installation video. Next, check the real-time data to verify that all the modules are showing as green, or producing power, and that grid voltage and frequency are okay. If you don't see the same number of microinverters communicating as you have installed, you'll want to check a few things. 1. Verify that the microinverter serial numbers have been entered correctly. 2. Verify the AC and DC connections on the roof and that all connections are seated properly. And 3. Verify the ECU Zigbee antenna is installed. AP Systems microinverters are rugged, durable, and designed to last. However, if you should experience a system problem such as an installed microinverter not communicating, here are a few tips to help you diagnose and resolve them. There are typically 3 areas where your problems may exist. A. The microinverter itself may be having problems, or B. The microinverter is working fine, but it's having trouble communicating with the ECU. Or C, the microinverter and ECU are operating normally and something else is causing problems. Please be aware that the majority of problems reported to the AP Systems call center are typically found to be in the category C. So before you call, it's important to first check a few things off your list to verify proper system operation. First, you want to verify the utility voltage and frequency are within the ranges shown in the technical data sheet for the product. This can be found in the resource library at apsystems.com. Next, check the connection to the utility grid. Verify utility power is present at the inverter in question by removing AC, then DC power. Please note, never disconnect the DC wires while the microinverter is producing power. Reconnect the DC module connectors and watch for the 3 short LED flashes. Check the AC branch circuit interconnection between all the microinverters. Verify each inverter is energized by the utility grid as described in the previous step, and make sure that all the AC breakers are functioning properly and in the on position. Check the DC connections between the microinverter and the PV module. Using a voltmeter, verify the PV module DC voltage is within the allowable range shown in the technical data sheet. If reconnecting the microinverter doesn't produce the 3 short green LED flashes, it's possible there's a microinverter problem. Check the LED on the microinverter unit. A red light, either blinking or solid, or no light at all, can mean a microinverter problem. If you see a steady red light on the microinverter, this means the unit has detected a GFDI, ground fault detection interruption error in the PV system. The microinverter will continue reporting the fault so long as the GFDI issue exists. You'll need to resolve this ground fault problem in the array. Once it's resolved, the error can be cleared and the light will change once again to slow blinking green. You can learn how to clear this and other errors in the ECUR installation manual in the resources library of AP Systems website. If you see no light, verify proper cabling and that connectors are properly seated. If you see a blinking green light, whether slow or fast, the issue is probably with the ECU. Let's take a look at diagnosing ECU problems. If there's no data being displayed for one or more microinverters in the ECU app, or EMA, this is likely a communication issue, not a microinverter problem. If the data display for all microinverters is erratic, where data appears sometimes and disappears at others, this is also likely a communication problem. If the data display for only one microinverter is erratic, but the rest report normally, it's likely a microinverter problem. If restarting the ECU does not resolve the problem, check connectivity of the homeowner's router. Verify their internet connection is working. Next, check the connection of the ECU to the router. If the ECU is connected via Wi-Fi, perhaps the homeowner changed their network password or ISP. Try connecting the ECU to the router using an Ethernet cable. If still unresolved, check the proximity of the ECU to the closest microinverter. Place the ECU temporarily closer to the array to see if proximity or an obstacle such as a metal roof may be the problem. If this resolves the issue, permanently relocate the ECU in a position to better communicate with the array. If the issue persists, contact technical support for diagnosis. Remember, an AP Systems support tech must be able to troubleshoot the issue online in order to send a replacement, so be sure not to disconnect or uninstall anything before the AP Systems team has had a chance to diagnose the system online. To contact AP Systems technical support, visit your local AP Systems website and navigate to the support page. Here you'll find the phone number for your local support team and a form to submit any issues you might be seeing.